Hello there, and welcome to Sleepy Civilizations. Tonight we're going to talk about something unsettling, something that sits at the edge of what we know and what we can never fully understand. We're going to explore the missing chapters of human history, the gaps, the silences, the periods where the record simply goes dark. And science, for all its power, can only offer educated guesses about what really happened. Imagine for a moment that you're holding a book, an ancient volume that contains the entire history of humanity. Now imagine that someone has torn out whole sections, not just pages, but entire chapters. The remaining pages are there, the binding still holds, but you're left with fragments. You can see that something came before and something followed after, but the middle, the explanation, the transition, it's just gone. That's what we're dealing with when we talk about the missing chapters of human history. Before we begin this journey, I'd love to know where in the world you're listening from tonight and what time it is where you are. It's a curious thing, isn't it? Here we are, separated by distance and time zones, yet connected by the same questions about our shared past. And if this kind of deep, contemplative exploration is something you enjoy, I'd be thankful if you'd consider tapping the like button or subscribing to Sleepy Civilizations. No pressure, of course, just an invitation to join us on this ongoing journey. So settle in, get comfortable, and let's begin our exploration of the missing chapters in time, where human history simply goes silent, and the scientific mysteries that keep researchers awake at night, even as they might help you drift peacefully off to sleep. When we say that a chapter of history is missing, what do we actually mean? It's not quite the same as saying we don't know something. There's a difference between lacking information and confronting a void so complete that we can barely frame the questions we should be asking. Think about it this way. If I asked you what you had for breakfast 3 Tuesdays ago, you probably wouldn't remember. That information is lost to you, but it existed. Someone who was with you might remember. There might be a receipt somewhere. The information is recoverable, at least in theory. But what if I asked you about something that happened, but left no trace whatsoever? What if the event occurred in a way that made it inherently unrecordable, or in a time before anyone was keeping records, or in a place where all records were systematically destroyed? That's the nature of the gaps we're exploring tonight. These aren't just things we haven't discovered yet. These are periods where the normal continuity of human life and civilization seems to have been interrupted so dramatically that the before and after are almost unrecognizable to each other. History, as we understand it, depends on continuity. One generation passes knowledge to the next. Cities are built on the ruins of older cities. Technologies evolve from earlier technologies. Languages shift gradually, maintaining threads of connection to their ancestors. But what happens when that continuity breaks? What happens when a civilization simply ends, not gradually fading away, but collapsing so completely that the survivors couldn't even explain to their children what came before? The archaeological record is full of these moments. Though we rarely think about them in such stark terms, we find layers of ash, we find abandoned cities, we find evidence of catastrophic climate change, we find genetic bottlenecks in human populations, we find gaps in the stratigraphic record that represent millions of years. And in each case, we're left asking the same fundamental question: what happened here? Science is exceptionally good at answering many questions about the past. We can date artifacts to within years or even months. We can analyze ancient DNA and trace population movements across continents. We can reconstruct past climates from ice cores and tree rings. We can read languages that no one has spoken for thousands of years. But there are limits to what science can recover. And those limits become especially apparent when we're dealing with catastrophic events that left few survivors and even fewer records. One of the most challenging aspects of studying these missing chapters is that we often don't know what we don't know. How many civilizations rose and fell completely without leaving any trace that we've recognized? How many technological achievements were made and then lost? How many migrations occurred that left no archaeological signature? The absence of evidence is not evidence of absence, as the saying goes, but it leaves us in a frustrating position. We can sense that something is missing. We can see the gap in the record, but we can't always say what should be filling it. Throughout this exploration, we're going to encounter several types of missing history. Some are geological, vast stretches of time where the physical record of the Earth itself has been erased. Some are archaeological, periods where human activity seems to have drastically reduced or changed in ways we can't fully explain. Some are technological, moments when advanced knowledge seems to have been lost, requiring centuries or millennia to rediscover. And some are epistemological, situations where we simply can't know what happened because the nature of the event itself prevented the kind of evidence we'd need to reconstruct it. What unites all of these missing chapters is a sense of profound humility they force upon us. We like to think of human progress as a steady accumulation of knowledge and capability. We imagine that each generation builds on what came before, adding to the great edifice of civilization. But the missing chapters remind us that progress is fragile, that knowledge can be lost, that entire ways of life can disappear so completely that their very existence becomes a matter of debate among scholars thousands of years later. There's something both terrifying and oddly comforting about this realization. Terrifying because it suggests that our own civilization, with all its accumulated knowledge and technology, could potentially face similar disruptions. Comforting because it shows us that humans have survived catastrophic losses before and rebuilt, adapted, continued. We are, at our core, a resilient species, capable of enduring and recovering from disasters that would seem to make continuation impossible. As we move through each of these missing chapters tonight, I want you to think about what it would be like to live through such a transition. Imagine being among the last people who remembered how things were before, trying to explain to your children or grandchildren a world they can barely comprehend. Imagine being among the first to emerge from the Dark Age, discovering ruins of achievements you lack the knowledge to understand or replicate. These aren't abstract historical questions. They're deeply human experiences that speak to our vulnerability and our strength in equal measure. Let's begin with perhaps the most dramatic missing chapter in all of Earth's history, and certainly the longest. It's called the Great Unconformity, and it represents a gap of up to 1 billion years in the geological record. To put that in perspective, 1 billion years is more than 20% of the entire age of the Earth. Imagine if 1/5 of all human history was simply missing, not just poorly documented, but physically erased from the planet. That's what we're dealing with here. The Great Unconformity was first recognized in the 19th century by John Wesley Powell during his famous 1869 expedition through the Grand Canyon. Geologists noticed something remarkable in locations around the world, from the Grand Canyon to Scotland to the Ozark Plateau. They found ancient rocks, in some places over 1.5 billion years old, sitting directly beneath much younger rocks from around 500 to 550 million years ago. Between these layers, representing what could be up to 1.2 billion years of Earth's history, the geological record simply vanishes. The rock that should tell the story of what happened during all that time is missing. This wasn't just a local phenomenon. The Great Unconformity appears in locations all around the world, suggesting that whatever caused these gaps had widespread, possibly global impacts. That's what makes it so remarkable and so puzzling. What kind of process or processes could remove so much of the geological record on such a vast scale? For decades, scientists debated the causes. The dominant theories focused on plate tectonics and erosion, the formation and breakup of supercontinents, particularly a supercontinent called Rodinia that existed about 1 billion years ago, would have created massive mountain ranges. These mountains would then have been eroded away over hundreds of millions of years, carrying away the intermediate layers of rock and depositing them in the oceans. This process, while slow, is powerful enough to remove enormous amounts of material given sufficient time. More recent research has brought another mechanism into focus: massive, global-scale glaciation. Around 720 to 635 million years ago, the Earth experienced what scientists call snowball Earth episodes. periods when ice sheets may have covered most or all of the planet's surface. The glaciers from these events would have been remarkably effective at scraping away surface rocks, grinding them down, and carrying the debris far from its origin. When the ice finally melted, it would have left behind a landscape radically transformed, with ancient basement rocks exposed and hundreds of millions of years of geological history removed. A study analysing rock samples from multiple locations across North America used a technique called thermochronology, examining how hot or cold rocks were at different times in their history. The researchers found evidence suggesting that massive erosion occurred during specific periods, though the exact mechanisms and timing varied across different regions. Some areas showed evidence of erosion beginning around 700 to 850 million years ago, before the major snowball Earth glaciations. Other regions displayed different patterns entirely. What has become increasingly clear is that the Great Unconformity may not be a single, uniform event with one cause. Recent research suggests it might be more accurate to speak of multiple Great Unconformities, plural, each forming at different times in different locations for potentially different reasons. Some may have been caused by tectonic uplift and erosion associated with the breakup of Rodinia. Others may have been carved by snowball Earth glaciation. Still others might have resulted from combinations of processes we're only beginning to understand. The implications reach far beyond geology. The period during and just after the time represented by the Great Unconformity corresponds with one of the most important transitions in the history of life on Earth, the emergence of complex, multicellular organisms. Before this period, life was relatively simple, mostly single-celled organisms, microbial mats, simple algae. After it, we see the explosion of complex life forms during what's called the Cambrian explosion, which would eventually give rise to all modern animals, including us. Could these events be connected? Some scientists think the massive erosion associated with the Great Unconformity would have released enormous amounts of nutrients into the oceans, potentially fertilizing the seas and creating conditions that favored more complex organisms. The global ice ages might have created evolutionary pressures that selected for new survival strategies. The breakup of supercontinents might have created new ecological niches and isolated populations that could evolve independently. But these remain hypotheses, fascinating possibilities suggested by the timing of events rather than proven causes. The truth is, we're still working to fully understand it. The Great Unconformity represents not just a missing chapter in geological history, but potentially a missing chapter in the history of life itself. We can see what came before in the ancient basement rocks. We can see what came after in the Cambrian fossils. But the transition itself, the actual processes by which one state became the other, remains largely obscured. The rock record that might explain it literally ground away by time and natural forces. What we can say with confidence is this: the Earth experienced transformations so profound that they erased up to 1.2 billion years of geological record in some locations. The planet was reshaped, and in the aftermath of that reshaping, life itself changed in ways that would ultimately make our existence possible. Whether these events are causally connected or merely coincidental remains one of geology's great questions, a reminder that even the ground beneath our feet holds mysteries we're only beginning to solve. As you lie there tonight, consider the sheer scale of what we're talking about. 1 billion years, 1,000 million years. During that time, continents moved, mountains rose and fell, ice advanced and retreated, life evolved in ways we can barely trace. And then it was all erased, ground down to nothing, leaving us with only the faintest traces of what once was. The Great Unconformity teaches us something important about the nature of missing history. Sometimes the gap isn't a failure of record-keeping or preservation. Sometimes the gap is the result of active destruction, of processes so powerful that they don't just hide the past, they erase it entirely. It's a humbling thought, and one that should make us wonder what other chapters might be missing from the geological record, gaps we haven't yet recognized, because we don't know what we're looking for. Now let's move from the deep geological past to something much more recent, yet in some ways even more mysterious, because it involves not just the Earth, but human civilization itself. Around 1200 BCE, something catastrophic happened in the Eastern Mediterranean and Near East. Within the span of perhaps 50 years, nearly every major civilization in the region collapsed. Not declined, not weakened, collapsed. Cities were destroyed, kingdoms fell, trade networks shattered, writing systems disappeared, and we still don't fully understand why. This event, known as the Late Bronze Age collapse, represents one of the most dramatic discontinuities in recorded human history. Before it, the Eastern Mediterranean was a thriving, interconnected world of powerful kingdoms and sophisticated cultures. The Mycenaeans in Greece built their palatial centers and grew wealthy from trade. The Hittites controlled a vast empire in Anatolia, modern-day Turkey. The new kingdom of Egypt stood at the height of its power, though it would be severely weakened by the crisis. The Kassites ruled in Babylonia. Cyprus thrived as a major center for copper production. Ugarit on the Syrian coast was a cosmopolitan port city where merchants from across the known world gathered. These civilizations were not isolated. They were connected by extensive trade networks, diplomatic relations, and cultural exchanges. Archaeologists have recovered letters between rulers discussing marriages, alliances, and trade agreements. We found shipwrecks, like the famous Uluburan wreck, carrying mixed cargoes from multiple regions. We know that tin traveled great distances to the Mediterranean, that amber from the Baltic reached Egypt, that ideas and technologies spread across vast distances. This was, in a real sense, the first globalized world. And then, beginning around 1225 to 1200 BCE, it started to come apart. The destruction unfolded over approximately 50 years, though the pace varied by region. Major cities across the Aegean were burned and abandoned. The Hittite capital of Hattusa was destroyed so thoroughly that it was never reoccupied. Mycenaean Greece saw the destruction of every major palatial center: Pylos, Mycenae, Tiryns, Thebes. The city of Ugarit was devastated so completely that it too was never rebuilt. Cyprus saw widespread destruction at some sites, though interestingly, some settlements there even seemed to flourish during this period. Even Egypt, which survived the crisis after fighting off multiple invasions, was severely weakened, losing much of its territory and influence. The costs of defending itself left Egypt's economy in tatters and its treasury nearly empty. In the wake of this collapse came what historians call the Greek Dark Ages, a period lasting several centuries during which writing disappeared from Greece, monumental architecture ceased, trade declined dramatically, and population levels dropped significantly. Similar Dark Ages affected other regions. The interconnected Bronze Age world was replaced by smaller, more isolated communities struggling to survive. So what caused this catastrophic collapse? That's the question historians and archaeologists have been trying to answer for over a century, and we still don't have a definitive answer. What we have instead are multiple theories, each supported by some evidence, but none able to fully explain the scale and simultaneity of the disaster. One of the most prominent theories involves the mysterious Sea Peoples. Ancient Egyptian texts, particularly inscriptions at the Temple of Medinet Habu from Pharaoh Ramesses III's reign, describe invasions by groups of foreign warriors coming from the sea. The Egyptians managed to defeat these invaders in major battles, first under Pharaoh Meneptah around 1207 BCE, and then again under Ramesses III around 1177 BCE. However, many other cities were not so fortunate, and widespread destruction followed their movements. The problem is, we don't really know who the Sea Peoples were or where they came from. The Egyptian texts give them tribal names: the Peliset, the Sherdan, the Luka, the Cheka, the Denayan, and others. But identifying these groups with known cultures has proven difficult. Modern scholars have proposed they may have originated from various regions around the Mediterranean, possibly including areas of Anatolia, the Aegean, or even further west? Were they displaced peoples fleeing some disaster of their own? Were they opportunistic raiders taking advantage of growing instability? The evidence remains frustratingly incomplete. What's become clear in recent scholarship is that the Sea Peoples theory, while it might explain some of the military destruction of certain cities, doesn't easily account for the broader pattern of collapse. Many sites show no evidence of violent destruction at all. They were simply abandoned. Trade networks failed across the region. Writing systems disappeared in places like Greece, not to return for centuries. The interconnected economic and political systems that had sustained Bronze Age civilization simply stopped functioning. Clearly, something more complex was happening than simple invasion. This has led historians to recognize that the Sea Peoples themselves may have been as much victims as aggressors, displaced by larger forces and contributing to the chaos rather than being its primary cause. Modern interpretations often present them as a symptom of the collapse rather than its root cause. Another theory that has gained substantial support focuses on climate change, specifically a severe and prolonged drought. Research analyzing sediment cores from the Sea of Galilee and other sites has identified evidence suggesting that the period from around 1250 to 1100 BCE experienced some of the driest conditions of the entire Bronze Age. Pollen analysis and other climate proxies indicate what some scholars describe as a mega drought that may have lasted decades, possibly even centuries in some regions. For civilizations that depended on agriculture to support large populations and complex societies, such conditions would have been catastrophic. Crop failures would have led to famine. Famine would have led to social unrest, migration, and conflict over remaining resources. Weakened states would have been unable to maintain their defenses or their trading relationships. Based on what we know about how ancient societies functioned, we can infer that these cascading failures could have overwhelmed even well-established kingdoms. However, while drought offers a compelling explanation for many aspects of the collapse, some questions remain. Egypt, which depends entirely on the Nile's annual floods, was weakened but survived the crisis. The Babylonians near the Tigris and Euphrates similarly endured. This could suggest that access to reliable river systems provided some protection, though it doesn't fully explain why other civilizations with diverse water sources struggled more severely. The relationship between climate stress and societal collapse appears to have been more complex than a simple one-to-one correlation. A third theory points to earthquakes. The Eastern Mediterranean is geologically active, and some researchers have proposed that a storm of earthquakes, an extended period of intensified seismic activity, might have destroyed cities and destabilized the region. Archaeological evidence shows that many Bronze Age sites exhibit signs of earthquake damage, collapsed walls, fallen columns, buildings pulled apart in ways consistent with seismic stress. The earthquake theory has the advantage of explaining the simultaneous destruction of multiple sites. A major earthquake storm could indeed wreak havoc across a wide region, but it struggles to explain why the destruction wasn't followed by rebuilding. Civilizations can recover from earthquakes, as we know from historical examples. Why didn't these Bronze Age civilizations rebuild? Other theories emphasize internal factors: social upheaval, slave revolts, peasant rebellions, the breakdown of centralized authority. The Bronze Age kingdoms were highly stratified societies with powerful elites controlling large populations. Perhaps the system became unsustainable. Perhaps the lower classes rose up. Perhaps the administrative complexity became too great to maintain. We know that some cities seem to have been destroyed from within, rather than by external invasion. Still, other theories focus on technological change, specifically the spread of ironworking. Iron, when properly smelted and worked, produces stronger tools and weapons than bronze. The traditional Bronze Age powers controlled the sources of copper and tin needed to make bronze, giving them both military and economic advantages. But iron is more widely available. If iron-working technology spread beyond the control of these traditional powers, it might have leveled the playing field. allowing previously subordinate peoples to challenge the established order. What's most likely is that the Bronze Age collapse wasn't caused by any single factor, but by a combination of these stresses acting together, what scholars call a systems collapse. The Bronze Age civilizations were highly interconnected, which made them efficient and prosperous, but also vulnerable. When multiple stresses hit simultaneously, drought, earthquakes, invasions, social unrest, the system couldn't absorb the shocks. Trade networks that depended on stability broke down. Cities that depended on trade couldn't get resources. Kingdoms that couldn't protect their cities lost legitimacy. One failure cascaded into the next, and the whole structure came apart. Interestingly, a recent medical study has proposed that infectious disease epidemics might have played a larger role than previously recognized. If populations weakened by drought and social stress were hit by outbreaks of diseases like smallpox, bubonic plague, or tularemia, it could have devastated urban centers and prevented recovery. Disease, unlike other explanations, could account for the abandonment of intact cities and the failure to rebuild. What makes the Bronze Age collapse particularly significant for our exploration of missing history is what was lost. Writing systems like Linear B disappeared from Greece and wouldn't return for centuries. Monumental architecture ceased. Long-distance trade largely ended. Artistic and technological sophistication declined. Entire ways of life, entire bodies of knowledge, simply vanished. Consider what this means. If you were among the last generation to grow up in a functioning Bronze Age palace, you would have been literate, part of a complex administrative system, aware of a wide world connected by trade and diplomacy. If you survived into the Dark Age that followed, your children would grow up illiterate, in a much smaller world, with no understanding of the complexity that had existed before. They might hear stories about the great kingdoms of the past, about mighty heroes and vast cities, but these would seem like myths, like fairy tales about a world that never really existed. And yet it had existed. The ruins were there. The legends preserved dim memories. But the connection, the continuity, the explanation of how one became the other, that was gone. That's the missing chapter. We can see the Bronze Age world in its height. We can see the Dark Ages that followed. But the transition, the actual experience of living through that collapse, remains largely inaccessible to us. Some cities have left us tantalizing fragments. At Ugarit, we have letters from the last days, urgent messages about enemies approaching, pleas for help that never came. And then nothing, the city destroyed, its people scattered or killed, its story ending mid-sentence. These letters are haunting because they show us people who had no idea they were living through the end of their world. They thought the crisis would pass. They expected help. They believed, as people always do, that their civilization would endure. The Bronze Age collapse teaches us several unsettling lessons. First, that even sophisticated, successful civilizations are vulnerable to systems collapse when multiple stresses compound. Second, that knowledge and sophistication can be lost surprisingly quickly when the systems that maintain them fail. Third, that the interconnectedness that makes civilizations prosperous can also make them fragile, turning local problems into systemic catastrophes. And fourth, that we might be living through the end of our own world without recognizing it until it's too late. As you drift off tonight, think about those final letters from Ugarit, those desperate messages sent into a void. Think about the children who grew up in the ruins, hearing stories of a world they couldn't quite believe had existed. Think about the missing chapter, the 50 years of collapse that transformed the known world and left a darkness that would take centuries to lift. Moving back in time again, let's explore another mysterious period, one that occurred much closer to our own origins as a species. About 12,900 years ago, something dramatic happened to Earth's climate. The planet had been steadily warming, emerging from the last ice age, glaciers retreating, forests spreading, temperatures rising. And then, suddenly, the warming stopped. In fact, it reversed. Within perhaps a few decades, maybe even faster, temperatures plummeted. The ice advanced again. The world that had been warming and opening up suddenly turned cold and harsh. This period, lasting about 100-200 years, is called the Younger Dryas, named after a small Arctic flower that thrived during cold periods. The Younger Dryas is significant not just because it was a return to Ice Age conditions, but because of how abruptly it began and ended. Geological evidence suggests that temperatures could have dropped significantly within a decade or less. That's climatologically instantaneous, far faster than any natural climate change we've observed in more recent times. The Younger Dryas coincides with several other significant events that make it particularly interesting and mysterious. During this period, many of North America's large mammals went extinct. Mammoths, saber-toothed cats, giant ground sloths, dire wolves, and many others. About 3/4 of the large animal species in North America disappeared. At the same time, the Clovis culture, the earliest widespread archaeological culture in North America, characterized by its distinctive stone tool technology, abruptly disappeared from the archaeological record. Are these events connected? Did the climate change cause the extinctions? Did the extinctions affect the human cultures that had depended on hunting these animals? Or was there some other factor, some catastrophic event that caused all of these changes simultaneously? In 2007, a team of scientists proposed a controversial hypothesis that the Younger Dryas was triggered by the impact or airburst of a comet or asteroid over North America. The evidence they cited included unusual microscopic particles found in sediment layers dating to the onset of the Younger Dryas, particles that they argued indicated high temperatures consistent with an impact event. They reported finding microspherules, nanodiamonds, high concentrations of certain metals, and other materials that seemed difficult to explain through normal geological processes. The hypothesis suggested that this impact might have had multiple cascading effects. It could have directly killed many large animals. It might have triggered massive wildfires across the continent. It could have disrupted climate patterns, perhaps by injecting large amounts of dust and debris into the atmosphere, or by destabilizing ice sheets and affecting ocean currents. All of this, the theory proposed, could have created conditions that led to both megafaunal extinctions and the end of the Clovis culture. If true, this would represent a catastrophe on a scale hard to imagine. A continent-wide disaster, mass extinctions, climate chaos, human populations devastated. It would be, in effect, a missing chapter in the story of human development in the Americas. A period of disaster so severe that it reset the trajectory of human culture in the region. However, the Younger Dryas impact hypothesis has been intensely controversial from the beginning and remains widely disputed within the scientific community. Other researchers attempted to replicate the original findings, often with mixed or negative results. They couldn't consistently find the same particles in the same concentrations at the reported sites. Many suggested that the materials identified as impact markers could be explained by other processes: volcanic activity, wildfires unrelated to impacts, or even contamination from modern sources. The debate became quite heated within academic circles. The scientific consensus today, as reflected in major reviews of the evidence, leans heavily toward the traditional explanation that the Younger Dryas was caused by a disruption of ocean circulation, specifically a weakening or shutdown of the Atlantic meridional overturning circulation. This disruption was likely triggered by massive freshwater releases from melting ice sheets flooding into the North Atlantic. This mechanism can explain the rapid cooling observed and is consistent with broader patterns of abrupt climate change during glacial periods. That said, research continues, and some findings keep the conversation alive. Studies have reported finding shock-fractured quartz and certain metal anomalies at multiple sites. In 2018, researchers identified a possible impact crater beneath the Hiawatha Glacier in Greenland, roughly 31 kilometers in diameter. While the dating of this crater remains uncertain and debated, and it may ultimately prove to be unrelated to the Younger Dryas, It demonstrates that impact events did occur during human history, even if this particular one wasn't responsible for the Younger Dryas cooling. What's interesting about this scientific controversy is what it reveals about how we evaluate extraordinary claims. The scientific method demands reproducible evidence, and when initial findings can't be reliably replicated, confidence in the hypothesis understandably declines. But the debate also shows how complex it can be to interpret ancient events from fragmentary evidence. Whether or not the Younger Dryas was caused by an impact, the period itself represents a missing chapter in human prehistory. We know it was a time of dramatic climate change, ecological disruption, and significant changes in human cultures. But the details of how people experienced and adapted to these changes, how they explained what was happening to them, how their societies transformed under this pressure, most of that is lost to us. Archaeological evidence from the Younger Dryas period is relatively sparse, which itself is suggestive. Where did people go during this cold period? How did they survive? What knowledge and technologies did they develop in response to these harsh conditions? We have some clues: changes in tool types, evidence of changing hunting strategies, signs of population movement, but the full picture eludes us. One thing that seems clear is that humans demonstrated remarkable adaptability. Despite the return to Ice Age conditions, despite the loss of many large game animals, despite the dramatic environmental changes, people survived. They adapted. They developed new strategies. They persisted. And when the Younger Dryas ended as abruptly as it began, warming again in perhaps as little as a decade, human populations were poised to expand and diversify rapidly. This period of rapid warming at the end of the Younger Dryas coincides with another major transition in human history, the beginning of agriculture in multiple regions around the world. Is this another coincidence, or did the stress of the Younger Dryas somehow prepare human societies for the agricultural revolution? Did the need to intensify food production during a difficult period lead to innovations that would ultimately transform human society? These are questions we can't fully answer because the crucial evidence, the lived experience of people during this time, the decisions they made, the knowledge they accumulated, is largely lost. The Younger Dryas is a missing chapter, not because nothing happened, but because what did happen is so difficult to reconstruct from the fragmentary evidence that remains. As you lie there in the dark tonight, imagine what it would have been like to experience the onset of the Younger Dryas. You've grown up in a warming world, ice retreating, new lands opening up, perhaps stories from your grandparents about harder times in their youth. And then, within your lifetime, within perhaps a few years, everything changes. The cold returns. The familiar animals start dying off. The plants you've relied on stop growing. The whole world seems to be reversing, going backward into a time of ice and scarcity. How would you explain it? What would you tell your children? How would you adapt? And then, just as mysteriously as it began, it ends. The world warms again, even more rapidly than it cooled. Spring returns, not gradually, but explosively. New opportunities appear. New challenges emerge. And you're left wondering what just happened and whether it might happen again. Now let's explore what may be the closest humanity ever came to complete extinction, an event that occurred about 74,000 years ago and left its mark not in the archaeological record so much as in our very genes. This is the story of the Toba supervolcano eruption and the population bottleneck that may have followed. Lake Toba in Sumatra, Indonesia, is a beautiful body of water, about 100 kilometers long and 30 kilometers wide. It's a popular tourist destination, peaceful and serene. But this lake sits in a volcanic caldera, the collapsed remains of a supervolcano, one of the largest and most dangerous geological features on Earth. And about 74,000 years ago, Toba erupted in what may have been the most powerful volcanic explosion in the last 2 million years. To give you a sense of scale, the Toba eruption was about 5,000 times larger than the 1980 Mount St. Helens eruption and perhaps 100 times larger than the 1815 Tambora eruption, which caused the year without a summer. Toba ejected an estimated 2,800 cubic kilometers of material into the atmosphere. That's about 670 cubic miles, enough to bury Texas in a meter-deep layer of ash. The eruption had a volcanic explosivity index rating of 8, the maximum on the scale, denoting a super-colossal event. The immediate effects would have been catastrophic for anyone in the region. The eruption likely lasted for days or weeks, covering much of Southeast Asia and India in thick deposits of volcanic ash. Some areas were buried under meters of debris. But the real impact was global. The massive amount of material ejected into the stratosphere would have affected the entire planet. When a volcano erupts, it doesn't just eject rock and ash. It also releases vast quantities of sulfur dioxide gas. This gas combines with water vapor in the stratosphere to form sulfate aerosols, tiny particles that reflect sunlight back into space. The result is volcanic winter, a period of global cooling that can last for years. For a super eruption like Toba, the cooling effect would have been dramatic. Estimates suggest global temperatures may have dropped by 3 to 5 degrees Celsius, with much larger drops in some regions. 5 degrees doesn't sound like much until you realize it's about the same as the difference between current global temperatures and the depths of the last ice age. Imagine a worldwide deep freeze happening not gradually, over thousands of years, but suddenly, within a few years of the eruption. Tropical regions experiencing frost, monsoons failing, growing seasons collapsing, fresh water sources freezing. For a species like early humans, living in small, dispersed populations and entirely dependent on being able to gather food from the environment, this would have been an extinction-level event. And this is where genetics comes in. When geneticists study the DNA of modern humans, they find something curious. We have remarkably low genetic diversity compared to many other species. In fact, human genetic diversity is so low that it suggests our entire species went through what's called a population bottleneck, a period when the total human population was reduced to a very small number, perhaps as few as 1,000 to 10,000 breeding pairs, maybe as few as 3,000 individuals total. A population bottleneck has a distinctive genetic signature. When a large, genetically diverse population is suddenly reduced to a small number of individuals, most genetic variants are lost. Only the genes present in that small surviving population can be passed on to future generations. When the population later expands again, everyone descends from that small group of survivors, and the genetic diversity remains low. It's like starting over with a limited genetic palette. The timing of this human population bottleneck, based on genetic analysis, appears to be somewhere between 50,000 and 100,000 years ago. That range overlaps with the Toba eruption. Could Toba have been the cause of the bottleneck? In 1998, anthropologist Stanley Ambrose proposed exactly this in what became known as the Toba catastrophe theory. According to this theory, the Toba eruption triggered a volcanic winter that lasted for years and potentially initiated or intensified a longer period of cooling that lasted 1,000 years or more. Human populations around the world would have struggled to survive under such harsh conditions. Most groups, the theory suggested, would have died out. Only a few isolated populations in refugia, places where conditions happened to remain just barely survivable, particularly in equatorial Africa, would have made it through. These survivors, this tiny remnant of humanity, were the ancestors of all living humans today. If the Toba catastrophe theory were correct, it would represent the most dramatic missing chapter in all of human history, a near-extinction event that reduced our species to perhaps a few thousand individuals scattered across the world, struggling to survive in the worst environmental conditions humans had ever faced. Almost everything from before this bottleneck would have been lost. Knowledge, technologies, cultural practices, stories. The survivors would have had to start over, rebuilding human society from the smallest possible foundation. It's a compelling narrative, and for a while, it seemed well supported by the available evidence. The timing of the genetic bottleneck overlapped with the Toba eruption. The scale of the eruption was certainly sufficient to cause global disruption. The theory offered an elegant explanation for a puzzling feature of human genetics. However, more recent research has significantly complicated and, in many scientific circles, largely undermined the Toba catastrophe theory. Archaeological discoveries have found human occupation sites in India, some quite close to the eruption site, that contain artifacts both below and above the layer of Toba ash. This suggests that human populations in the region not only survived the eruption, but continued their activities through the immediate aftermath. Similar evidence has been found at sites in Africa and elsewhere, indicating that human populations were more resilient than the catastrophe theory assumed. Climate modeling has also raised questions. While the eruption certainly would have had severe short-term effects, recent studies suggest that the cooling may not have been as prolonged or as globally uniform as the original catastrophe theory required. Some regions would have been more severely affected than others. Equatorial Africa, where much of human evolution took place, appears to have remained relatively habitable throughout the period, which could explain why African populations show evidence of surviving the bottleneck better than populations elsewhere. Moreover, the genetic evidence itself has become more complex. While humans clearly experienced a population bottleneck during the late Pleistocene, the timing and severity vary somewhat depending on which populations are studied. Non-African populations show a particularly severe bottleneck, with effective population sizes dropping dramatically around 50,000 to 70,000 years ago. African populations also show evidence of a bottleneck, but it appears somewhat different in timing and perhaps less severe, with populations recovering earlier. This pattern has led to alternative explanations. One proposal, called the Arabian standstill, suggests that human populations migrating out of Africa through the Arabian Peninsula were caught in a period of severe climate stress that may have been exacerbated by the Toba eruption, but wasn't solely caused by it. These small, migrating populations, already stressed by adapting to new environments outside Africa, were hit with harsh glacial conditions and nearly died out. African populations, being larger and more established, weathered the crisis better. So we're left with a more nuanced picture than the original Toba catastrophe theory presented. Something clearly happened to reduce human populations drastically during the late Pleistocene, with genetic evidence pointing to a bottleneck sometime between 50,000 and 100,000 years ago. The Toba eruption was certainly a major environmental catastrophe that would have stressed human populations globally. Whether Toba was the primary cause of the population bottleneck, a significant contributing factor, or largely coincident with it, remains a matter of ongoing scientific debate and research. What's not in doubt is that there's a missing chapter here. Whether caused by Toba specifically, or by a combination of climate stress, glacial conditions, and the challenges of human migration, humans went through a period of severe population reduction. During that time, most of human genetic diversity was lost. Small, isolated populations struggled to survive. Knowledge and cultural practices would have been lost as groups died out. Technologies might have been forgotten and had to be rediscovered later. The current scientific consensus, based on archaeological evidence showing continued human activity before, during, and after the eruption, along with improved climate models and genetic analyses, suggests that while Toba was certainly disruptive, it probably did not bring humanity to the brink of extinction on its own. Human populations demonstrated more resilience and adaptability than the catastrophe theory initially assumed. Imagine being among those survivors. You might have been one of only a few thousand humans alive on the entire planet. You might have gone your entire life without meeting anyone outside your own small group. The world would have seemed vast and empty and cold. The knowledge of your grandparents, the old ways of doing things, would have been precious beyond measure because there was no one else to learn from if your group lost that knowledge. And yet humans survived. We adapted, we persisted, we eventually thrived. From that reduced population, probably numbering in the low thousands, we've grown to nearly 8 billion. That's both humbling and hopeful. Humbling because it reminds us how close we came to disappearing entirely. Hopeful because it shows how resilient and adaptable our species can be. As you drift towards sleep tonight, consider what it means that we all carry in our genes the legacy of that bottleneck. That we all descend from a surprisingly small number of ancestors who survived whatever crisis befell humanity around 70,000 years ago. They faced conditions we can barely imagine. They lost most of what their ancestors had known and built, but they survived. And in surviving, they gave us the gift of existence. Now let's shift gears and explore a very different kind of missing chapter, not a geological or catastrophic event, but a more unsettling idea that whole periods of recorded history might not have happened at all, or at least not in the way we think. This brings us to the peculiar theory known as the phantom time hypothesis. In 1991, a German historian named Heribert Illig published a provocative theory. He proposed that the early Middle Ages, specifically the years from 614 to 911 AD, never actually occurred. According to Illig, these 297 years were essentially fabricated, added to the calendar by a conspiracy involving Holy Roman Emperor Otto III, Pope Sylvester II, and Byzantine Emperor Constantine VII, who wanted to place themselves at the symbolically significant year 1000 AD. Now, before you dismiss this as pure conspiracy theory, it's worth understanding what led Illig to propose such an outlandish idea. He was grappling with a legitimate historical and calendrical puzzle. When the Gregorian calendar was introduced in 1582 to replace the older Julian calendar, it made a correction of 10 days. But based on the known discrepancy between the Julian calendar and the solar year, the correction should have been 13 days, not 10. Where did those 3 extra days come from? Illig's answer: 297 years of phantom time never actually elapsed. Illig pointed to other issues as well. The period in question, parts of the early Middle Ages, is often called the Dark Ages because historical documentation from this period is relatively sparse, especially compared to the periods before and after. Archaeological evidence is thin in some regions. Some architectural achievements seem too advanced for when they were supposedly built, and there are gaps and inconsistencies in various historical chronicles from the period. Moreover, Illig argued that the most significant historical figure of the era, Charlemagne, might be entirely fictional, a legendary composite rather than a real person. The Carolingian Renaissance attributed to Charlemagne's reign seemed, to Illig, too culturally sophisticated for the supposed time period. The phantom time hypothesis captured public imagination, particularly online, because it plays into several fascinating ideas about the malleability of history, the potential for massive deception, and our dependence on authority to tell us what's true about the past. If nearly 3 centuries of European history could be fabricated, what else might not be as it seems? The problem, of course, is that the hypothesis doesn't hold up under scrutiny. The evidence against it is overwhelming. We have historical records from outside Europe, from the Islamic world, from China, from the Byzantine Empire, all of which align with the European timeline. Astronomical events that can be dated precisely, solar eclipses, comets, the position of stars, all match the established chronology and would be different if 297 years were missing. Archaeological evidence, while admittedly patchy in some regions, is nonetheless present and shows clear continuity with the periods before and after. Linguistic evolution shows the expected gradual changes that require the passage of time. Technologies evolved in ways that make sense only if the full timeline is accepted. And the supposed calendar anomaly that started the whole thing can be explained by different methods of calculation used at different times. As for Charlemagne being fictional, we have contemporary accounts from multiple independent sources, physical artifacts from his reign, and a well-documented historical context for his empire. While details may have been embellished, and legends certainly grew up around him, there's no serious doubt among historians that Charlemagne was a real person. So the phantom time hypothesis is, by scholarly consensus, wrong. But it's worth spending time on because it highlights something important about missing chapters in history. The hypothesis emerged because there are real gaps, real uncertainties, real puzzles in the historical record. The Dark Ages got that name for a reason. Documentation is indeed sparse for parts of this period. Our understanding of medieval European history does have holes in it. The hypothesis was wrong, but the gaps it tried to explain are real. Moreover, the phantom time hypothesis reminds us how dependent we are on continuity and consensus in reconstructing the past. We trust that the calendar is accurate because we trust the institutions that maintain it. We accept the standard chronology because the weight of evidence supports it, and because countless historians have worked to establish and verify it. But what happens when that continuity is broken? What happens to our understanding of history when records are destroyed, when oral traditions are lost, when continuity is severed? There's a related, even more extreme theory called the New Chronology, proposed by Russian mathematician Anatoly Fomenko, which claims that all of recorded history is much shorter than we think, essentially compressing everything before about 1000 AD into just a few centuries. This theory is even more thoroughly debunked than phantom time, but it emerged from similar observations about gaps, inconsistencies, and puzzles in the historical record. The reason these fringe theories gain traction, despite being contradicted by evidence, is that they speak to a real anxiety about the fragility of historical knowledge. They remind us that the past is not directly accessible to us. We can't go back and check. We're dependent on the evidence that has survived, on the accuracy of records kept by people who had their own biases and limitations, on the chains of transmission that brought information from then to now. Real missing chapters in history exist not because of conspiracies, but because records were never made in the first place, or were made but not preserved, or were preserved but later destroyed. War, fire, flood, deliberate destruction, simple neglect, all of these have erased countless chapters of human history. We know the library at Alexandria contained vast amounts of knowledge that was lost when the library was destroyed over a series of incidents. We know that when the Spanish conquered the Americas, they systematically destroyed indigenous texts and suppressed indigenous knowledge systems. We know that countless cultures throughout history have had rich oral traditions that disappeared when the last speakers died without passing on their knowledge. These are real missing chapters, and they're far more tragic than any fabricated timeline. The gaps in our knowledge exist not because someone added phantom years to a calendar, but because the actual records and materials and memories of the past were lost, sometimes deliberately, sometimes through accident, sometimes simply through the passage of time and the entropy it brings. What phantom time theories get right, though perhaps inadvertently, is that our understanding of the past is always provisional, always dependent on incomplete evidence, always subject to revision when new information comes to light. They remind us to maintain a healthy skepticism about historical claims, to demand evidence, to be aware of how history can be manipulated by those in power. These are valuable lessons, even if the specific theories are baseless. As you lie there, consider what it would take to actually erase a period of history from the record. You'd need to destroy or alter all contemporary documents. You'd need to somehow modify all archaeological evidence. You'd need to align all the independent records from different cultures. You'd need to adjust astronomical observations. You'd need to coordinate this across generations and geographic regions. It's essentially impossible, which is why these conspiracy theories fail. But consider too what is actually lost from history through more mundane means. Consider all the stories that were never written down, all the innovations that were forgotten, all the people who lived full lives and left no trace, all the cultures that disappeared entirely, absorbed or destroyed or simply faded away. Those are the true missing chapters, and unlike phantom time, they're real, they're permanent, and they represent losses we can never fully recover. We've talked about several specific missing chapters in human history, but now let's step back and think about the nature of historical preservation itself. Why do we have such gaps in our knowledge? What determines whether information from the past survives or disappears? Understanding this helps us appreciate both what we do know and what we can never recover. The archaeological and geological records are not comprehensive archives of the past. They're more like accident reports. documenting whatever happened to survive under specific, often unusual circumstances. Most of what has happened in Earth's history has left no trace that we can detect. Most organisms that have lived never fossilized. Most human activities left no durable evidence. Most knowledge was never written down or was recorded in ways that didn't survive. The past is not preserved, most of it is lost, and what remains is a highly biased sample. Think about what it takes for something from the past to survive to the present. First, it has to be made of durable materials. Stone, fired clay, metal under the right conditions. These can last for thousands or even millions of years. But wood rots, paper burns, textiles decompose, leather decays. Most of what humans make is not made to last. It's made to serve a purpose in the present. When that purpose is fulfilled, the object is discarded, and unless conditions are exactly right for preservation, it disappears. Second, it has to avoid destruction. War destroys deliberately. Natural disasters destroy randomly. Development destroys systematically as old cities are built over. Fields are ploughed. Mountains are quarried. Even without violent events, the simple processes of erosion, chemical weathering, and biological decay are constantly breaking down the physical remnants of the past. Third, it has to be buried or protected somehow. Exposure to the elements accelerates decay. But burial preserves, especially in dry environments, in frozen ground, in anoxic conditions where decomposition is slow. Many of the best preserved archaeological sites are ones that were rapidly buried by a disaster, a volcanic eruption, a flood, a landslide that created a time capsule. Fourth, it has to be in a place that remains geologically stable. Plate tectonics is constantly recycling the Earth's crust, particularly ocean floor, which is all relatively young geologically. Regions subject to mountain building, glaciation, or other tectonic activity are constantly being reworked. Only relatively stable continental shield regions preserve very old materials. Fifth, it has to be found. Even if something survives, if it's buried too deep, or in an inaccessible location, or simply in a place no one happens to look, it might as well not exist for our purposes. Archaeology is limited by where we dig, and we can only dig a tiny fraction of the Earth's surface. And finally, it has to be recognized as significant. How many artifacts have been found and discarded because the finder didn't realize what they were? How many sites have been destroyed by construction before archaeologists could study them? How many fossils have eroded out of rock faces and disintegrated before anyone saw them? Given all these filters, it's remarkable we know anything at all about the deep past. And it helps explain why we have such significant gaps. The missing chapters of human history are missing not primarily because of dramatic events that destroyed the evidence, though those certainly happen, but because of the ordinary processes of time acting on materials that were never meant to last. This preservation bias affects what we know in specific ways. We know much more about elites than about common people, because elites had resources to create durable goods and monuments. We know more about urban centers than rural areas, because cities concentrate material culture. We know more about death than life, because burials are intentional depositions that create preservable contexts. We know more about violence than peace, because destruction events create archaeological signatures. We know more about some periods than others, based on accidents of preservation and research focus. Consider something as basic as ancient population sizes. How many people lived in a given region at a given time? This seems like it should be a straightforward question, but it's actually very difficult to answer. We can count the number of archaeological sites from a period, but many sites are still undiscovered, others have been destroyed, and we don't know how many people lived at each site or for how long. We can look at burial grounds, but many burial practices don't leave preserved remains. We can study settlement patterns, but these change over time and are often incompletely preserved. The result is that our population estimates for prehistoric periods are often very rough, sometimes varying by orders of magnitude depending on the methods and assumptions used. We simply don't have the data to be precise. This introduces uncertainty into our understanding of demographic history. which in turn affects our understanding of cultural development, resource use, environmental impact, and many other aspects of the past. Or consider technology. We talk about the Stone Age, Bronze Age, and Iron Age as if the transition between these periods was sharp and universal. But the reality is much messier. Different regions transitioned at different times. Some technologies were adopted, then lost, then rediscovered. Some innovations that seem obvious to us in retrospect took thousands of years to develop or spread, and we only know about the technologies that left durable traces. What about technologies that used perishable materials? What about knowledge that was never embodied in physical objects at all? There's a concept in archaeology called the behavioral inference problem. We find material remains, tools, structures, burials, and we try to infer from these what people were doing, thinking, believing. But the inference is difficult and always uncertain. The same artifact might have had multiple uses. The same structure might have served different purposes at different times. The absence of something might mean it was never there, or that it was there but didn't preserve, or that we haven't found it yet. This is why archaeological interpretations are always provisional and subject to revision. A new discovery can overturn long-held theories. A new analytical technique can reveal previously invisible information. A shift in theoretical framework can lead to reinterpretation of old evidence. The past is constantly being rewritten, not because historians are unreliable, but because our access to the past is always mediated through incomplete and biased evidence. The situation is even more challenging for periods before writing. Prehistoric societies left no texts to explain themselves. Everything we know comes from material remains interpreted through analogies with better documented societies. We make educated guesses based on patterns, on comparisons, on careful analysis, but we're always aware that we might be wrong, that we're necessarily seeing these cultures through our own cultural lenses, that we're missing huge amounts of information that would have been obvious to the people who lived through it. And then there's oral history. Many cultures transmitted knowledge, stories, genealogies, technical information orally rather than in writing. When the chain of transmission is broken, when the knowledge holders die without passing on their knowledge, when a language becomes extinct, when a culture is destroyed or assimilated, that information is lost utterly and completely. No amount of archaeological excavation will recover a story that was only ever told aloud. Some oral traditions have proven remarkably stable over long periods. Indigenous Australian peoples have oral histories that may extend back thousands of years, describing events and landscapes that can be corroborated by geological evidence. But many oral traditions have been lost, particularly when cultures came under pressure from colonization, disease, or forced assimilation. These represent missing chapters of human experience that can never be recovered. Even for literate societies, preservation of written records is challenging. Paper is vulnerable to fire, water, insects, and time. Libraries burn, archives flood, documents crumble to dust. We've lost the vast majority of books written in the ancient world. We have perhaps 7 of the 120 plays Sophocles wrote. We have fragments of countless works that we know existed, only because they're referenced in other texts. Entire libraries, entire genres, entire literary traditions have been lost. And in the modern era, we face new preservation challenges. Digital information seems permanent, but is actually quite fragile. File formats become obsolete. Storage media degrades. Digital platforms close down. Much of the early internet has already been lost. Future historians might have better documentation of the 19th century, when newspapers were printed on paper and letters were written in ink, than of the early 21st century, when so much information exists only in volatile digital formats. As you drift off tonight, think about what traces your own life is leaving. What will survive? If archaeologists 1,000 years from now tried to reconstruct your life, what would they find? Probably not much that's personally identifiable. Maybe some metal objects, maybe foundations of buildings, maybe some very degraded plastics. The richness of your experience, your thoughts, your relationships, your daily activities, almost none of that would survive in a form they could access. You would be a missing chapter in the history they're trying to reconstruct. And multiply that by billions of people over thousands of years, and you begin to understand the scale of what's missing from the human story. We're not just missing isolated facts or specific events. We're missing the vast majority of human experience. What we know is the thin surface layer, the small fraction that happened to leave durable traces, that happened to be preserved, that happened to be found and recognized. The rest is silence. We've journeyed through several missing chapters tonight, from a billion-year gap in Earth's geological record, through the mysterious collapse of Bronze Age civilizations, the sudden climate reversal of the Younger Dryas, the possible near extinction of humanity during the Toba eruption, the curiosities of calendar time and phantom history, and finally, the fundamental challenges of historical preservation. Each gap teaches us something important about the fragility of knowledge, the vulnerability of civilization, and the immense power of time to erase. These missing chapters share some common themes. First, they remind us that continuity, the thing we take most for granted, is actually quite fragile. Knowledge must be actively maintained and transmitted, or it disappears. Civilizations must continuously adapt and rebuild, or they collapse. Even the physical record of the Earth itself is constantly being erased and overwritten. Second, they show us that catastrophic disruptions are not just theoretical possibilities, but actual events that have happened repeatedly in Earth's history and in human history. We've survived ice ages and volcanic winters, droughts and earthquakes, population bottlenecks, and civilizational collapses. Each time, we've had to start over in some sense, rebuilding from a reduced base, recovering lost knowledge, adapting to new circumstances. Third, they demonstrate the limits of what we can know about the past. Despite all our scientific tools and methods, despite centuries of research and mountains of accumulated evidence, there are simply some things we cannot recover. The gaps are real. The missing chapters will remain missing. We have to learn to live with uncertainty, to accept that our understanding of history is always incomplete and always provisional. But there's something oddly comforting about this humility. The missing chapters remind us that human beings have faced existential challenges before and survived. We've been reduced to small populations and recovered. We've lost civilizations and built new ones. We've forgotten knowledge and rediscovered it. We're a resilient species, adaptive and creative, capable of surviving and eventually thriving even after catastrophic setbacks. The missing chapters also give us perspective on our own time. We live in an era of unprecedented knowledge preservation. We have libraries, archives, databases, multiple redundant copies of important information stored in different formats and locations. We have scientific instruments that can detect faint traces of the past that previous generations couldn't even imagine existed. We have global communication networks that make coordinated knowledge preservation possible. And yet, we're also creating new vulnerabilities. Our complexity makes us fragile in some ways. Our interconnectedness, like that of the Bronze Age civilizations, means that problems in one area can cascade globally. Our dependence on technology means that if key systems fail, we might lose access to vast amounts of information. Our environmental impact is creating conditions that could trigger their own catastrophes. The missing chapters are not just puzzles about the past. They're warnings about the future. They tell us that nothing is guaranteed, that civilization is not a steady climb, but a precarious balancing act, that we need to actively work to preserve knowledge and maintain continuity because time and entropy are constantly working against us. So what should we take away from our exploration of these missing chapters? Perhaps simply this: respect for the fragility of knowledge, appreciation for the continuity we do have, awareness of the vast amount we don't know and likely never will know, and a determination to preserve and transmit what we've learned to future generations. The missing chapters will always be with us. We'll never recover everything that's been lost. But by understanding what's missing and why, we can better appreciate what we do have. We can work to fill in the gaps where possible. We can preserve more carefully what exists now. And we can maintain the humility that comes from recognizing how much of the human story remains and will always remain unknown. As you finally drift off to sleep tonight, carried by these thoughts of deep time and missing chapters, know that you're part of the ongoing human story, a story that has many gaps and many mysteries, but that continues nonetheless. Tomorrow will add its own page to that story. What we choose to preserve, what we choose to remember, what we choose to pass on, these become the chapters that future generations might be able to read. The rest, like so much before, will eventually fade into the silence, becoming another mystery for future archaeologists to ponder as they try to piece together what life was like in our time. Thank you for joining me on this journey through the missing chapters of human history. If you enjoyed this exploration, please consider liking and subscribing to Sleepy Civilizations. We'll continue to explore the deep questions, the quiet mysteries, and the long perspectives that help us understand our place in the vast sweep of time. Until next time, sleep well and dream of the gaps between what was and what might have been.